Hello and welcome to this video on transformations. So the idea of transformations in general is to try and move an object around some space. So there are four ways that we can transform things. The first one is translation, which just means that we've just moved it essentially. So we're just taking it from this position and we're moving it to this position. So this is just moving the shape. Now we also can have rotations, where, as it says, we're just rotating the shape around a point. So we just rotate the shape. The third one is reflections. So we just reflect the shape in a line. And the last one is enlargements, where we enlarge the shape. Okay, so these are the four things that we can do. So we can move it, we can rotate it, we could reflect it, or we can enlarge it. Okay, so I'm going to work on these grids, and the first thing that I'm going to go through is just translation. So translation, meaning moving the shape. So let's say I had a square that was over here. So I have a square, and that's an awful square. Let's make it a rectangle, why not? Where this point here has the coordinates of, let's go with -3 and 2. Okay, where this is your y-axis and this is your x-axis. So we have the coordinates of this point. Now, in the question, they'll give you the coordinates for all 4 points. I would say, just as a general rule, find one point and translate that first. And then as you do more practice, you'll find that you'll translate that one point and be able to just redraw the graph, redraw the shape, whatever it may be. Tends to be the quickest way to do things. If you really need to, you can just go through and translate each point by whatever the translation vector is. So the translation vector, what I mean by that is that we often say translations as we move it maybe 3 to the left and 1 up, or 2 to the right and 3 down. But we can write that in a more sophisticated way by using column vectors. And they look like this, where we have an x and y translation. Now this is not a fraction, so we don't put a line in between. The top part just refers to whether we're moving in the x direction. So if, say, for example, we had a 3, so x was 3, it means we're moving 3 steps towards the right, so towards the positive x-axis. Now if it was -3, we'd have 3 steps to the left. We'd move in the opposite direction. And the same for y. If y was +7, we'd move 7 steps up the y-axis. If y was -7, we'd do 7 steps down. So that's all these column vectors will tell you. So they'll just tell you how you need to move along the x-axis and along the y-axis. So let's take an example then. Let's say I want to translate this vector by translate the shape by the vector of, let's go with 4 and -2. Okay, this is the column vector. Now this one up here, remember it, is the x, and the bottom one is the y. So I want to take this point here and I want to move it 4 steps across. So 4 steps across from -3 is going to be +1. So I'd put a preliminary point there, but then I've also got this -2 that's going to take me down the y-axis 2. And so that's going to, if I'm originally at +2, it's going to take me down to 0. So this is my new position of this point here. And then I can take that and just draw out the rest of my shape. And you've translated that shape there. Now they can sometimes give you a question where they might tell you that this is shape A and this is B, where A is a translation of B, and they might say describe one single transformation that has occurred to get from A to B. And in this case, because the thing's just been moved, we would say that it's a translation by the vector 4 - 2. Okay, so your first mark comes from saying translation, and your second mark comes from saying the vector. Okay, and that's translation. Then next of all, we can think about reflections. Let's do reflections next. So reflections, as you can probably tell, are when we reflect something about a line of symmetry. So let's say I had a triangle now. So let's say I have a triangle over here, and the question might ask you to reflect the triangle A. So reflect triangle A in the line y is equal to 0. Now the line y is equal to 0 is just the x-axis. So all we're doing is we're seeing that this x-axis is our line of symmetry, and in your exam you might get tracing paper, in which case you would just put your tracing paper over this, sketch out the shape but also the line, and then just flip your piece of paper over, line up the line again, and then just draw your shape, and you'll find that your shape will come out down here like this, and then label that one B. If you are not a fan of tracing paper, there is another way that you could work this out. So you could say that let's give this a coordinate of 2, 1 maybe, this point here. We could say that if we know that it's 2 away from the line of symmetry going upwards, then when we, 1 away from the line of symmetry going upwards, then when we flip it, it's going to have to be 1 away. So this point here is going to have to be in -1. Okay, and from there you could do the same thing with this. That's going to have to go down to there, and this one, let's say this was 4 away, this would have to come down here at -4. So we'd have that method of working it out as well if you needed to. But the line y equals 0 is quite a nice example. Sometimes they might tell you reflect it in the line y equals x maybe. And now if we get rid of these shapes and have a look at how I would reflect something in y equals x, well, let's have a to try and make it a nice one to understand, let's make it a rectangle up here. Okay, and the line, so reflect, let's call this C. So reflect C in the line y equals x, meaning it's this diagonal going across here and coming back down here. Okay, this is the line y equals x, because where this is 1, this is 1, where this is 2, this is 2, and it goes on for the whole thing. But if we want to reflect this, again, if you have tracing paper, you can just sketch over it, sketch over the line, and then flip it over, and then sketch it out here. If not, you can see how far this is away from here, and you'll see that it has to be the same on that side as well. Same there. There we go. Same for this second one, it would have to be the same over there, and then you could sketch out this and label it D. Okay, so this is how we're going to have reflections. When you are asked to recognize that something is a reflection, you get 1 mark for noticing that it's a reflection. You get your second mark for saying what the line of reflection is. So you would say it's been reflected in the line y equals 1 or x equals 5 or whatever it might be. Okay, so that's reflections. We can now look at rotations. So rotations are exactly what they sound like. We're just going to take a shape and we're going to rotate it about a point. Okay, so let's take an example. So let's say I wanted to rotate this triangle here. So this triangle A about the origin. Yeah, let's go with a nice easy one. So rotate A about the origin. Okay, and so they would have to specify in the question the amount of degrees. So it would be rotate A, and we're going to go with 90 degrees about the origin. Okay, so what we would do, again, if you have tracing paper, it would be ideal to just put the tracing paper over the top, sketch out the shape A, place the dot where it is, and try and keep that dot stationary and rotate the paper at 90 degrees. And what you'll find is that you'll get something that will look a bit, when you move this around, it's going to come down here, this is going to go like this, and this is going to end up looking like this. It's a very rough sketch. Let me try that one again. There we go. And that would be B, when we rotate it through 90 degrees through the point of the origin. Excuse me. Okay, so now that we can rotate shapes around that point, what would happen if we had a shape that we would have to rotate about a weirder point? So the origin is quite a nice place for them to ask you to rotate. Let's say now we take this shape, let's make it a better rectangle. We take this shape, which I'm going to call C again, and we want to rotate C about the point. Let's say rotate C 180 degrees about 1, 1. So we're going to find 1, 1, and that's that point there. So we want to rotate the shape about this point 180 degrees. So what we would do, again, if you have tracing paper, just put your tracing paper over, sketch out the shape and the dot, keep the dot stationary, rotate the paper around it, and you'll find that you'll get an upside down rectangle about here. Now it's much closer to the origin than it is in this quadrant here, and that's because we have to keep it centered on this point here. So it's not being centered on the origin like last time, so we have to center it here, which means that we have to keep the same distance away here as we do here. Now obviously this is not drawn as accurately as it could have been drawn. It's just here to try and show you how to recognize that these are rotations. So if they ask you in a question to recognize a rotation and write a sentence, they would say that this is, your first thing is to say that it's a rotation. Your second thing is to say the angle that it's been rotated through. So you'd say it's a rotation through 90 degrees. The third thing is to say the center of rotation. So in this case it was 1, 1, or the origin. So you'd say it's a rotation 90 degrees around the origin, and your fourth thing would be to specify if it's clockwise or anti-clockwise, because they will have very different motions. Okay, and I believe finally we're going to look at enlargements. Now enlargements, we're going to take a shape and we're going to change the size of that shape from a point. So in enlargements we need to have a scale factor. So we need to see by how much are we going to increase or even decrease the size of this object. And so if we take let's say we take a square here that is 1, 1, this is going to be 2, 2. Okay, so this is 1, 1, this is 2, 2, this is 2, 1, and this is 1, 2. And let's say I wanted to enlarge, again, shape A. So I want to enlarge A by a scale factor of 2 from the origin. Okay, so I do have a point that I have to enlarge from. So I'm enlarging from this origin here. So what that means is the reason we have a point is we have to double the distance from the origin to each of these points. Okay, so you can either do these directly, or you can say that if it's 1 across and 1 up, it's now going to become 2 across and 2 up. So this point here is actually going to be the lowest point when we have shape B. Now if we're going 1 across and 2 up to get to this point, then we need to go 2 across and 4 up. So let's make this 4 to get to that point. Then if we're going 2 across and 1 up to get to here, it's going to be 4 across. So let's make this 4 and 2 up to get to there. And then finally, if it's 2 across and 2 up, it's going to become 4 across and 4 up. And so we've enlarged this shape by a scale factor of 2 from the origin. Okay, and you can see that because if you were to expand all of these lines, they should pass through the points. And that's just the nature of this enlargement. Now we could also have had a scale factor of 1/2. So if we wanted to, so this is going from A to B, this enlargement here. If we wanted to go backwards and go from B to A, we would say that this would be an enlargement of B by a scale factor 1/2 of 1/2. Okay, that's because we essentially halved the distance to all of the points from the origin. And so not only could we have enlarged this thing, but we can also reduce the size of this thing by just flipping the scale factor that we're working with. Okay, so that is enlargements. When we're asked to recognize enlargements, we need to first get our mark by saying that this is an enlargement. We get our second mark by saying the scale factor by which it's enlarged by, and we get the third mark for saying the origin of the enlargement. And those are the 4 types of transformations that we have. So we're going to go through 2 questions of each transformation, so rotation, reflection, translation and enlargement, one by one, and then hopefully we'll get a better understanding of how we're going to approach these questions. So let's start with this first rotation question. So they ask you to rotate triangle R about a half turn about the point O. So the point O is the origin at the center, and we want to rotate a half turn. This half turn is just 180 degrees. Okay, so if we had a full turn, it would be 360 degrees around a point. A half turn, 180 degrees. A quarter turn would be 90 degrees. And so with a half turn, if you weren't familiar with this, you could also tell that it would be 180 degrees since there's no direction. So it doesn't matter if we go clockwise about this point or anti-clockwise, because we're going to get to the same point anyway, because we're just basically flipping it around. Okay, so if we wanted to do that, in the exam you might get tracing paper. You could just sketch out your shape, put your pencil on your origin and then rotate around 180 degrees, but I don't have any tracing paper for this. So I'm just going to pick a point that I can recognize, and I'm going to rotate that point 180 degrees, and then I'm going to do this for each point separately. So if this becomes 3 across and 1 up, if I were to rotate it through 90 degrees, it would become 3 down and 1 across, so it would be about here. And then if I wanted to rotate this point through 90 degrees again, it would become 3 across and 1 down, so it would be there. Okay, so this point relates to this point here. Okay, then let's have a go at doing it for this point here. Well, this point is now 5 across and 1 up, so it would be 5 down and 1 across, so it would be there, and then it goes 5 across and 1 down. And then finally, this last point at the top here is 3 across and 4 up, so 3 across, 3 down and 4 across would be there, and then 3 across and 4 down is here, and then we draw a new triangle and then label it T. So all we've done is just rotate this triangle around the origin through 180 degrees. Now the second question asks us to describe fully the single transformation that maps P onto Q. So that's going from here to here. And because this has changed the orientation of it, we can reduce some of these options. So we'd go through, is it a rotation, is it reflection, is it translation, or is it enlargement? The only two that will change the shape or the orientation of the shape would be rotation and reflection, since translation is we're taking the shape and we're just moving it around, and enlargement is we'd look for the shape being bigger or smaller. If it's the same size, we have to then choose whether it's reflection or whether it's rotation. And the way we're going to do that is just to simply see, is there a possible line that this could be reflected in? And this one, you can kind of use your intuition. It's not really going to be a reflection kind of question, so we're going to go with rotation. So this is a rotation. So we get our first mark from saying that it's a rotation. We then want to say the angle that it gets rotated through, which in this case is 90 degrees because we're just flipping from this quadrant here to this quadrant here. We want to say whether that's clockwise or anti-clockwise. Well, if we're going around this way, it's clockwise. And then we want to say what point it's rotated around. Okay, so if we know that this is rotating around this way, then the point that we have must be in between or around this kind of area down here, because it has to be about a point down here in order for it to rotate around. So I'm going to choose this point because I know that that maps onto that point, and this rotates around here. And what I know about these things is that the point of rotation, the point that we rotate around, isn't going to move, which means that it has to be an equal distance away from this point on P here and this point on Q here. So we have to find a point in this region down here that is an equal distance away from both of these things. So you could trial and error with this. So let's say we take this for example. Obviously this isn't going to be the correct answer, but if we were to assume that, then we could check. We'd say that this is 2 lines away from here, and from this one we'd have to go across 3 and up 1, so that can't be the right one. Let's check 1 1, and then we can see that we have to go 1 across and 2 up, and here we have to go 1 up and 2 across, and it might not look the same, but because we've rotated it, it is actually the same distance that we have to travel to get from there to there, because it's across 1 or up 1, across 2, and then across 1, up 2. And so our point is this point here, which is 1 1. Okay, and that's how we would approach those rotation questions. Now let's have a look at reflection. So this first question asks us to reflect the triangle in the line y equals 1. And again, you could use tracing paper, but we're going to stick it out with a systematic approach. I'm going to say that I know this line y equals 1 is actually drawn for you in this question, but I wouldn't rely on that being the case for all of them, because they can just tell you to reflect the line, reflect the triangle or the shape in this line, and you're expected to know that this is y equals 1. But let's say this is y equals 1. This point here on the triangle is going to be reflected past this line, and so we're just going to make sure the distance from the line of reflection is the same. So here we've got 2 going up, so if we reflect it, it's basically going to jump down to here, and it has to be 2 down. So this point here is what's going to relate to that point there. Then we could relate this point here to that point up there, because they're both 2 away. And this point up here is 5 away, so it would have to be down here, which would also be 5 away. And then you would just draw the rest of your shape, and that's your reflected triangle. Now this question is a little bit trickier, because they've asked you to do more than one reflection, and then they're asking you for the single transformation to get from the very start to the very end of these 2 transformations. So they've originally given you shape P, and they're now saying that shape P is reflected in the line x equals minus 1. Now x equals minus 1 is this line here, because all across this line, no matter what y value we have, x is always equal to minus 1. So we want to reflect it in this line, x is equal to minus 1. So if this is the important part of the line, because that's the part we need to make sure is equidistant, it's very similar to this question where they're two away, so they need to be 2 away. So we're going to have that, and then you can kind of just draw the reflection of this going across here. So this is the reflection of P, and they've told you that this should give shape Q. Then they've said that shape Q is reflected in the line y equals 0, which is the x-axis. So we now want to rotate through y equals 0 to give shape R. So these are 1 away, so we're going to have 1 there and 1 there. This one is 3 away, so that's going to be 3 away from that point. So that's going to be, oh, apologies. That's going to be there, and then the last one is there, and then we join up all of these lines and we get shape R. So these are our reflections. So you can be asked to do these kind of reflections all the time, but in this case we've now asked to describe fully the single transformation. So we've just done 2 different transformations. So we've reflected it once, then reflected it again. But they want to know, is there a single transformation that takes you straight from P to R? And this is a common style question where we're basically saying, if you'll notice, it's very common that you'll get 2 reflections, and 2 reflections can always give you a rotation. Okay, and so this is what we've got here. So these 2 reflections give us a rotation. Since we've changed the orientation of it and we flipped it around, it's 180 degrees, because you've gone from this quadrant through this quadrant to this quadrant. It doesn't matter if it's clockwise or anti-clockwise in this case, because it's 180 degrees. So it's a rotation 180 degrees about the point, and then we have to choose where the point is. But with these ones, it's always quite nice, because this point where the 2 lines of symmetry overlap is the point of rotation, and that point is -1, 0, and that gives us full marks for that question. Okay, so now let's have a look at translation. So in translation, we're just looking to move the thing. So this first one is we're translating shape P by the vector of 5 minus 2. If you remember these column vectors, we said the column vectors had this form where the x translation was on the top and the y was on the bottom. So we want to pick a point. Let's pick this point, and we want to move it, and because this is positive 5 here, it's going to be 5 to the positive x direction, So then that becomes 1, 2, 3, 4, 5 here. But we also want to move this by -2, so it goes down 2 in the y direction. So it becomes here. Okay, now from here, moving one of them is good enough. You can then just realize that this length is 2, so that has to go there. This length is also 2. This length goes for 3. Then you just fill in the rest of the shape. Okay, and that's a translated shape for that. Now this one, we want to describe fully the single transformation that maps B onto C. Now we haven't changed the orientation. We haven't enlarged it by any amount, so that means it has to be a translation. So translation by vector, and we're looking at going from B to C, so we're going this way. So we pick a point, and we know that, let's go with this point, is going to map onto that point there. So we look at how many have we gone across. So that's 1, 2, 3, 4. So the vector is 4, and then we've gone down 1, and so that means it becomes -1, and that's our translation vector. And finally, let's look at enlargements. So they've given you this shaded triangle, and they want you to enlarge the shaded triangle by a scale factor of 2 about the center 0. So the center is the origin, and they want you to double the distance between the origin and all of the points. Okay, so you can do it like this and then double the distances. I would personally say think about them a point at a time. So let's choose this top point up here first. In order to get to this point from the origin, I have to move 1 across and then 3 up. So if I were to double that, I would have to move 2 across and then 6 up. So this is the top point now. Okay, so that's that point done. Let's now do this point here. To get to this one, I have to go down 1 and across 1. So to double that, I'm going to go down 2 and across 2. So this is going to be that point there. And this final one, I'm going down 1 and across 3. So it's going to become down 2 and across 6. So it's going to be there. And then you would get a ruler in your exam and fill out the shape. And then that's your enlarged shape there. Notice it does overlap, that is okay. And then lastly, describe fully the single transformation which takes shape A onto shape B. So because we know it's gotten bigger, it's an enlargement. We also need to know the scale factor, but we can look at the scale factor because we can see that this length is 1 and this length is 3. So this thing must have been enlarged by a factor of 3, because if you look on all sides, this is 1, this is 3, this is 2, this is 6, and so it must have been a scale factor of 2. So it's 3. It's an enlargement by a scale factor of 3 from the center, and we need to find the point that is 3 times as far away from this point on B as it is from this point on A, and that would be the origin here. Now, this is quite a nice one because we only have to go through 1 square to get to A, whereas we have to go through 3 squares to get to B, and so the center is 0, 0, or the origin. Okay, so that is 2 questions on each of these transformations. Hopefully this helps, and thank you for watching.